Okay, welcome back. Now we're going to look at some code. So here we have a basic NN module where we have two linear layers, a ReLU, and we just do linear, ReLU, linear. And we have an input tensor, we initialize our module, and this is the interesting part. So we specify a path on disk. So in this case, we just put something in temp, and we torch compile, and then after that we call AOT compile, and then we call save. And what this will do is we'll save an artifact to this path. And later on we read from this file, then we load the compiled function, and then we invoke it. It's like, it took a little bit of time for me to derive this, but basically this is args and this is quargs. And then when you invoke it, you have to pass in your module, and then you pass in your args and quargs. Yeah, at a high level, this is kind of the interface of precompile. So now if we run it, we will see, we'll just kind of step through the main important parts of the code. We'll look at the stack traces, just get a high level overview of what's going on. And then in future lectures, we're going to deep dive into specific parts of it. Okay, so we breakpoint here. And if we run this, I've already set a few breakpoints. So here is where a lot of the magic happens. So as we see, if we go up to stack trace, this for.aot compile calls AOT compile, which calls AOT compile full graph. And this is where the AOT stuff happens. And we jump forward. I guess it takes some time because it's actually compiling. You can see that it's done the compilation, and now it is about to return, and it's basically just packaging things up. So it's packaging things up in this compiled artifacts, and then this compiled artifacts is getting packaged in this AOT compiled function. And if we look at this forward callable, it's kind of interesting. So this is just returning a function, right? And this is the bytecode of the function. And then these are kind of like the environment that the function is going to execute in. And the magic happens here, where we are setting the backend ID, the global backend ID, to be this compiled function. And this compiled function is what is returned by inductor. And so the way to interpret this is that this bytecode is going to massage the inputs into the calling convention, which is just a tuple of args that AOT autograd expects, that the inductor compiled artifact expects. So it's going to grab things out of the global, it's going to grab things out of members, it's going to grab things out of the inputs, and it's going to just construct the args that this compiled function expects, and then it will invoke this compiled function. So if we continue, then we see that when we call save compiled function, that comes here. That's kind of weird that, oh, sorry, yeah, it's because right next to each other. When we call save compiled function, we basically will open the file, and then we'll write this AOT compiled function.serialize. And here you can see all of the serialization code, which basically takes all of our state and then gives us a serializable byte string that we'll write to the file. And if we continue, we get to the deserialize, and this we're loading the data. Now, interesting, you'll notice that we basically read the file, and then we call deserialize with these bytes, and we're just unpickling it. So like the format of the data stored is just a pickled object. And yeah, so at this point we kind of deserialize it back to this compile artifacts. And then we have a callable again, and then we can invoke it, and then things will just work. So if you see, it actually ends up printing out just as if we had called torch.compile without doing this AOT compile thing. And lastly, like this part, right? Like right now it's in the same file, it's on the same server, but in theory we could have saved it, we could have uploaded it to S3 or some other store and downloaded it and then loaded this on other machines, and it would just work. So yeah, that's a high level overview of the code. We're gonna dive a lot more into detail in future lectures, but hopefully this was helpful.